you're doing well this week. The topic for this week is going to be adding and subtracting rational expressions with unlike denominators. Last week we did an introduction to adding and subtracting rational expressions, and we did a couple of examples where we did add with like denominators, and I believe one example with unlike denominators. We are going to continue this week with more advanced examples, and all of these are going to have unlike denominators, so we're going to have to find the least common denominator in every single one of these problems. So here's example one. Example one is w over 6d k squared plus 3d squared y squared over 2c cubed k cubed. So we need to find the common denominator between 6dk squared and 2c cubed k cubed in order to add this. So, first of all, we're going to look at the numbers. The common denominator between 6 and 2 is actually going to be 6 because we can multiply 2 by 3 and get 6. And now, in order to find the common denominator when it comes to the variables, we simply multiply by the missing variables. So this has a d, so over here we're going to have to multiply by a d in the numerator and in the denominator. This has a c cubed, but this does not. So on this side, we're going to have to multiply by c cubed in the numerator and in the denominator. Now notice both of them have k, so this has k to the third and this has k squared. So the common denominator between k squared and k to the third is going to be k to the third. Now we already have k to the third here. In order to get k to the third here, we need to multiply top and bottom by k. So let's go ahead and do the next step here in order to find the least common denominator. So in the next step, we're going to have w over 6d k squared, and we're going to multiply this by the values that are missing. So we're missing a c cubed, so we're going to multiply by c cubed top and bottom. And it looks like we're missing one of the k, so we're also going to multiply by k. So now on the other expression, on the second term, we have 3d squared, y squared. Y squared over 2c cubed k cubed, and we're going to multiply this by the missing values. And here we have 6, here we have 2. I need a 6, so we're going to multiply by 3 in the numerator and in the denominator. And it looks like we're missing the d. So we're going to multiply by d. And it looks like that's the only thing else that's missing. So we're going to go ahead and simplify, and then we're going to add them after we simplify. So simplifying here, we're going to multiply these two numerators, and I want to put them in alphabetical order. So I'm going to put c cubed first, followed by k, and then times w, over. We're going to put the number first, 6 first, and then we're going to go in alphabetical order. So we're going to put c to the third next, followed by d, and then k squared times k is going to be k to the third, plus, over here, we're going to multiply 3 times 3, that's going to be 9. Then we're followed by a d to the third power because I have d squared and d, so we have d to the third. And then we have y squared, and this is in alphabetical order, so we're good to go there. Now we're going to have 2 times 3, that's going to be 6. And then going in alphabetical order, we're going to have c to the third, followed by d, followed by k to the third. Now, notice the denominators here. They are identical. I have 6c cubed d k cubed, 6c cubed d k cubed. They are the same. I have common denominators now. So when I have common denominators, I can simply add the numerators. So we're going to say c to the third, k, w, plus 9 d to the third y squared, and all of that is going to be over 6 c cubed d k cubed. And then we check, is there anything to factor and reduce? And it doesn't look like there's anything to factor. This doesn't have a coefficient in front other than 1. This has a coefficient of 9. There doesn't seem to be any common variables between them. So there is nothing that I can factor and reduce. So this is our sum. This is our final answer here. Okay, if you want to take a moment to pause and write down these steps, please do so at this time. And we're going to move on to example 2. Okay, so here we have example 2. Example 2, as you can see, we have 17 over 5x minus 10 minus 2 over x minus 2. And as I said earlier, we have unlike denominators. Our denominators are different. We have binomials this time, and they will have a common factor. So in order to show that, I need to factor my denominators wherever necessary first. So in the next step, I'm going to have 17 over, and I can factor a 5 out of this first denominator. So we're going to write 5, open parentheses. 5x divided by 5 is going to be x. Negative 10 divided by 5 is going to be negative 2. So there's our factors. Minus 2 over, and x minus 2, there's really nothing we can factor there. So we're just going to write x minus 2. Now, notice I have a factor of 5 and x minus 2 in the first term, and I just have a factor of x minus 2 in the second term. So we have a common factor of x minus 2. So this term already has x minus 2 in the denominator, so it doesn't need another x minus 2, and it also has 5. This already has x minus 2, so it doesn't need another x minus 2, but it is missing the 5. So on this side, we need to multiply by 5 over 5 in order to get common denominators. So now we're going to continue here, and we're going to say 17 over 5 times x minus 2 minus, and now we're going to multiply. 2 times 5 in the numerator is going to be 10 over, and then x minus 2 times 5, well, that's just going to be 5 times x minus 2. And as you can see, we have common denominators now. So that means we can just add the numerators. So we're going to say 17 minus 10 in the numerator all over 5 times x minus 2. We just put it all together. And now we can subtract 17 minus 10, which is just going to give us 7 over 5 times x minus 2. And that is our sum and or difference. Okay. And that is example 2. In the next video, I am going to show you another example that's a little bit more complicated. We are going to move on to trinomials.